Having identified initial velocity, acceleration, and final velocity for the appropriate interval, we can use the equations of motion to determine delta t and delta s. We note that we've got v naught, so we circle all our v naughts. Got a, so we circle all our a's. And we've got vf, so we circle all our vf's. Then we note that this equation has all the quantities except delta t, so we can solve this for delta t. This one has all the quantities except delta s, so we could solve this one for delta s. Okay, solving vf equals v naught plus a delta t. For delta t, we subtract v naught from both sides, and we get a delta t equals vf minus v naught, and then we divide both sides by a. We get delta t equals vf minus v naught over a, and then we can plug in our quantities. Vf is 0, v naught is 2 meters per second, and a is negative 10 meters per second squared. We get 0.2 seconds. Now you can compare this with the way we got the 0.2 seconds here. It comes out practically identical. But we had to do a couple of reasoning steps before we could get to this. So now we know delta t. Now we have a couple of choices. We could find delta s now that we know delta t just using vf, v naught, and our found value of delta t. If we're using the equations, it's really better not to use the quantity we just found, but to go ahead and use a different equation to find the next quantity, and then use all that information to see if everything is complete. However, having found a delta t, we can also just go back to direct reasoning and multiply the average velocity by delta t as we did here, and not have to get involved with this equation. But I want to illustrate the use of the equations. So, and if I ask you to solve by equations, you've got to do this. So we solve this equation for delta s. We subtract v naught squared from both sides. We get 2a delta s equals vf squared minus v naught squared. We then divide both sides by 2a, getting delta s, vf squared minus v naught squared divided by 2a. And then we plug our vf 0 and our v naught 2 meters per second and square those, subtract. Our denominator is 2 times the negative 10 meters per second squared. Let me fix that. So when we divide the meters per second squared in the numerator by the meter per second squared in the denominator, remember we invert and multiply the units of the denominator, and we end up with units of meters. We end up with 0.2 meters. So all of our results here are in agreement with the results that we got over here. And there's reason for that, because of course the equations just give you a simple form in which to do the reasoning, but the reasoning is often simpler than the equations. So you got to be able to use both.